Telecine is the process of transferring motion picture film into video and is performed in a color suite. The term is also used to refer to the equipment used in the post-production process. Telecine enables a motion picture, captured originally on film stock, to be viewed with standard video equipment, such as television sets, video cassette recorders, DVD, Blu-ray disc or computers. This allows film producers, television producers and film distributors working in the film industry to release their products on video and allows producers to use video production equipment to complete their filmmaking projects. Within the film industry, it is also referred to as a TK, because TC is already used to designate timecode. History of Telecine: with the advent of popular broadcast television, producers realized they needed more than live television programming. By turning to film-originated material, they would have access to the wealth of films made for the cinema in addition to recorded television programming on film that could be aired at different times. However, the difference in frame rates between film and television meant that simply playing a film into a television camera would result in flickering. Originally, the kinescope was used to record the image from a television display to film, synchronized to the TV scan rate. This could then be replayed directly into a video camera for redisplay. Non-live programming could also be filmed using the same cameras, edited mechanically as normal, and then played back for TV. As the film was run at the same speed as the television, the flickering was eliminated. Various displays, including projectors for these video rate films, slide projectors and film cameras were often combined into a film chain, allowing the broadcaster to queue up various forms of media and switch between them by moving a mirror or prism. Color was supported by using a multi-tube video camera, prisms, and filters to separate the original color signal and feed the red, green and blue to individual tubes. However, this still left films shot at cinema frame rates as a problem. The obvious solution is to simply speed up the film to match the television frame rates, but this, at least in the case of NTSC, is rather obvious to the eye and ear. This problem is not difficult to fix, however. The solution being to periodically play a selected frame twice. For NTSC, the difference in frame rates can be corrected by showing every fourth frame of film twice, although this does require the sound to be handled separately to avoid skipping effects. A more convincing technique is to use do-3 pull-down, discussed below, which turns every second frame of the film into 3 fields of video, which results in a much smoother display. PAL uses a similar system, 2-2 pull-down. In recent decades, Telecine has primarily been a film-to-videotape process, as opposed to film-to-air. Changes since the 1950s have primarily been in terms of equipment and physical formats. The basic concept remains the same. Home movies are videotapes of films that use this technique, and it is not uncommon to find Telecine DVDs where the source was originally recorded on videotape. The same is not true for modern DVDs of cinematic films, which are generally recorded in their original frame rate. In these cases, the DVD player itself applies telecining as required to match the capabilities of the television receiver. Frame rate differences. The most complex part of Telecine is the synchronization of the mechanical film motion and the electronic video signal. Every time the video part of the Telecine samples the light electronically, the film part of the Telecine must have a frame in perfect registration and ready to photograph. This is relatively easy when the film is photographed at the same frame rate as the video camera will sample, but when this is not true, a sophisticated procedure is required to change frame rate. To avoid the synchronization issues, higher-end establishments now use a scanning system rather than just a Telecine system. This allows them to scan a distinct frame of digital video for each frame of film, providing higher quality than a Telecine system would be able to achieve. Normally, best results are then achieved by using a smoothing rather than a frame duplication algorithm to adjust for speed differences between the film and video frame rate. Similar issues occur when using vertical synchronization to prevent screen tearing, which is a different problem encountered when frame rates mismatch. 2-2 pull-down equals, in countries that use the PAL or SECAM video standards, film destined for television is photographed at 25 frames per second. The PAL video standard broadcasts at 25 frames per second, so the transfer from film to video is simple. For every film frame, one video frame is captured. Theatrical features originally photographed at 24 frames are shown at 25 frames. While this is usually not noticed in the picture, the 4% increase in playback speed causes a slightly noticeable increase in audio pitch by just over 0.679 semitones, which is sometimes corrected using a pitch shifter, though pitch shifting is a recent innovation and supersedes an alternative method of Telecine for 25 frames formats. 2-2 pull-down is also used to transfer shows and films, photographed at 30 frames per second, like Friends and Oklahoma, to NTSC video, which is 60 Hz scanning rate. Although the 4% speed increase has been standard since the early days of PAL and SECAM television, recently a new technique has gained popularity, and the resulting speed and pitch of the Telecine presentation are identical to that of the original film. This pull-down method is sometimes used in order to convert 24 frames material to 25 frames. Usually, this involves a film to PAL transfer without the aforementioned 4% speed up. For film at 24 frames, there are 24 frames of film for every 25 frames of PAL video. In order to accommodate this mismatch in frame rate, 24 frames of film have to be distributed over 50 PAL fields. This can be accomplished by inserting a pull-down field every 12 frames, thus effectively spreading 12 frames of film over 25 fields of PAL video. The method used is 2-2-2-2-2-2-2-2-2-2-2-2-3 pull-down. This method was born out of a frustration with the faster, higher-pitched soundtracks that traditionally accompanied films transferred for PAL and SECAM audiences. A few motion pictures are beginning to be Telecined this way. It is particularly suited for films where the soundtrack is of special importance. When a TV station in an NTSC region airs a film or show that uses a PAL printing version, but is being broadcast in the NTSC format, sometimes they don't perform the proper PAL to NTSC pull-down conversion or it is done improperly. This causes the program to be sped up slightly and/or sound higher-pitched, due to the faster rate of the PAL 576 line/50 Hz versus the NTSC 480 line/60 Hz format. Some DVD releases of TV shows movies, such as The Archie Show, of which the episodes were broadcast in NTSC format, but the masters were either lost or damaged beyond usage, uses PAL 576/50 printings with 3-2 pull-down having not been performed properly, resulting in slightly faster film speed and higher pitch. Though some scenes in a few episodes use NTSC footage due to the PAL masters being missing, and the footage being damaged beyond use, causing varying shifts in speed, pitch, and film quality. 2-3 pull-down equals. In the United States and other countries where television uses the 59.94 Hz vertical scanning frequency, videos broadcast at 29.97 frames. For the film's motion to be accurately rendered on the video signal, a Telecine must use a technique called the 2-3 pull-down, also known as 3-2 pull-down, to convert from 24 to 29.97 frames. The term OE pull-down comes from the mechanical process of OE pulling the film downward within the film portion of the transport mechanism, to advance it from one frame to the next at a repetitive rate. This is accomplished in two steps. The first step is to slow down the film motion by 1/1000 to 23.976 frames s. The difference in speed is imperceptible to the viewer. For a 2-hour film, play time is extended by 7.2 seconds. The second step of the 2-3 pull-down is distributing cinema frames into video fields. At 23.976 frames, there are 4 frames of film for every 5 frames of 29.97 frames video. These 4 frames are restricted keyed into 5 by exploiting the interlaced nature of 60 Hz video. For every frame, there are actually 2 incomplete images or fields, one for the odd-numbered lines of the image, and one for the even-numbered lines. There are, therefore, 10 fields for every 4 film frames, which are called A, B, C, and D. The Telecine alternately places A frame across 2 fields, B frame across 3 fields, C frame across 2 fields and E frame across 3 fields. This can be written as AABBBCCDDD or 2-3-2-3 or simply 2-3. The cycle repeats itself completely after 4 film frames have been exposed. A 3-2 pattern is identical to the one shown above except that it is shifted by 1 frame. For instance, a cycle that starts with film frame B yields a 3-2 pattern, BBBCCDDDAA or 3-2-3-2 or simply 3-2. In other words, there is no difference between the 2-3 and 3-2 patterns. In fact, the 3-2 notation is misleading because according to SMPTE standards for every 4-frame film sequence the first frame is scanned twice, not 3 times. The above method is a classic 2-3, which was used before frame buffers allowed for holding more than 1 frame. The preferred method for doing a 2-3 creates only 1 dirty frame in every 5. While this method has slightly more jitter, it allows for easier reconversion and a better overall compression when encoding. The 2-3-3-2 pattern is supported by the Panasonic DVX100B video camera under the name Advanced Pulldown. Note that just fields are displayed no frames, hence no dirty frame is an interlaced display such as on a CRT. Dirty frames may appear in other methods of displaying the interlaced video. Other pull-down patterns similar techniques must be used for films shot at easy-lent speeds of less than 24 frames, which includes home movie formats as well as silent film. 16 frames to NTSC 30 frames, pull-down should be 3444, 16 frames to PAL 25, pull-down should be 33333334, 18 frames to NTSC 30. Pull-down should be 334, 20 frames to NTSC 30, pull-down should be 33, 27.5 frames to NTSC 30, pull-down should be 32222, 27.5 frames to PAL 25, pull-down should be 12222. Also, other patterns have been described that refer to the progressive frame rate conversion required to display 24 frames video on a progressive display. 24 frames to 96 frames, pull-down is 44, 24 frames to 120 frames, pull-down is 55, 24 frames to 120 frames, pull-down is 64. Telecine jitter . The A-A23 pull-down Telecine process creates a slight error in the video signal compared to the original film frames that can be seen in the above image. This is one reason why films viewed on typical NTSC home equipment may not appear as smooth as when viewed in a cinema and PAL home equipments. The phenomenon is particularly apparent during slow, steady camera movements which appear slightly jerky when telecined. This process is commonly referred to as Telecine jitter. Reversing the 2-3 pull-down Telecine is discussed below. PAL material in which 2-2-2-2-2-2-2-2-2-2-2-3 pull-down has been applied, suffers from a similar lack of smoothness, though this effect is not usually called a Telecine jitter. Effectively, every 12th film frame is displayed for the duration of 3 PAL fields, whereas the other 11 frames are each displayed for the duration of 2 PAL fields. This causes a slight overlap in the video about twice a second. It is increasingly being referred to as Euro pull-down as it largely affects European territories. Reverse Telecine, reverse pull-down, some DVD players, line doublers, and personal video recorders are designed to detect and remove 2-3 pull-down from Telecine video sources, thereby reconstructing the original 24 frames film frames. This technique is known as a Euro or EVC or a Euro inverse Telecine. Benefits of reverse Telecine include high-quality non-interlaced display on compatible display devices and the elimination of redundant data for compression purposes. Reverse Telecine is crucial when acquiring film material into a digital non-linear editing system such as Lightworks, Sony Vegas Pro, Avid, or Final Cut Pro, since these machines produce negative cut lists which refer to specific frames in the original film material. When video from a Telecine is ingested into these systems, The operator usually has available a Telecine trace, a in the form of a text file, which gives the correspondence between the video material and film original. Alternatively, the video transfer may include Telecine sequence markers a burned in a to the video image along with other identifying information such as time code. It is also possible, but more difficult, to perform reverse Telecine without prior knowledge of where each field of video lies in the 2-3 pull-down pattern. This is the task faced by most consumer equipment such as line doublers and personal video recorders. Ideally, only a single field needs to be identified, the rest following the pattern in lockstep. However, the 2-3 pull-down pattern does not necessarily remain consistent throughout an entire program. Edits performed on film material after it undergoes 2-3 pull-down can introduce a or jumps a in the pattern if care is not taken to preserve the original frame sequence. Most reverse Telecine algorithms attempt to follow the 2-3 pattern using image analysis techniques, for example by searching for repeated fields. Algorithms that perform 2-3 pull-down removal also usually perform the task of deinterlacing. It is possible to algorithmically determine whether video contains a 2-3 pull-down pattern or not, and selectively do either reverse Telecine or deinterlacing. Telecine hardware equals flying spot scanner equals. In the United Kingdom, Rank Precision Industries was experimenting with a flying spot scanner, which inverted the cathode ray tube concept of scanning using a television screen. The core emits a pixel-sized electron beam which is converted to a photon beam through the phosphors coating the envelope. This dot of light is then focused by a lens onto the film's emulsion, and finally collected by a pickup device. In 1950 the first Rank flying spot monochrome Telecine was installed at the BBC's Lime Grove studios. The advantage of the FSS is that color analysis is done after scanning, so there can be no registration errors as can be produced by Vidicon tubes where scanning is done after color separation it also allows simpler diachroics to be used. In a flying spot scanner or cathode ray tube Telecine, a pixel-sized light beam is projected through exposed and developed motion picture film and collected by a special type of photoelectric cell known as a photomultiplier which converts the light into an electrical signal. The beam of light OE scans across the film image from left to right to record the horizontal frame information. Vertical scanning of the frame is then accomplished by moving the film past the CRT beam. In a color Telecine the light from the CRT passes through the film and is separated by diachroic mirrors and filters into red, green and blue bands. Photomultiplier tubes or avalanche photodiodes convert the light into separate red, green and blue electrical signals for further electronic processing. This can be accomplished in a or to mere 24 frames per second. Rank Precision's Sintel introduced the OE marker series of FSS Telecines. During this time advances were also made in CRTs, with increased light output producing a better signal-to-noise ratio and so allowing negative film to be used. The problem with flying spot scanners was the difference in frequencies between television field rates and film frame rates. This was solved first by the MK. A polygonal prism system, which was optically synchronized to the television frame rate by the rotating prism and could be run at any frame rate. This was replaced by the MK2 twin lens, and then around 1975, by the MK3 hopping patch. The MK3 series progressed from the original E jump scan interlace scan to the MK IIIB which used a progressive scan and included a digital scan converter to outputs interlaced video. The MK IIIC was the most popular of the series and used a next-generation digiscan plus other improvements. The Mark series was then replaced by the Ursa, the first in their line of Telecines capable of producing digital data in 4:2:2 color space. The Ursa Gold stepped this up to 4:4:4 and then the Ursa Diamond, which incorporated many third-party improvements on the Ursa system. Sintel's Seriality and ITK's Millennium Flying Spot Scanner are able to do both HD and data. Line array CCD equals. The Robert Bosch GmbH, Fern C divide, which later became BTS Incorporated Philips Digital Video Systems, Thomson's Grass Valley and now as DFT Digital Film Technology introduced the world's first CCD Telecine, the FDL-60. The FDL-60, designed and made in Darmstadt, West Germany, was the first all-solid-state Telecine. Rank Sintel and Marconi Company both made CCD Telecines for a short time. The Marconi Model B3410 Telecines sold 84 units over a 3-year period, and a former Marconi technician still maintains them. In a charge-coupled device line array CCD Telecine, AA Whittier light is shone through the exposed film image into a prism, which separates out the image into the 3 primary colors, red, green and blue. Each beam of colored light is then projected at a different CCD, one for each color. The CCD converts the light into electrical impulses which the Telecine electronics modulate into a video signal which can then be recorded onto videotape or broadcast. Philips BTS eventually evolved the FDL-60 into the FDL-90/Quadra. In 1996 Philips, working with Kodak, introduced the Spirit Data Scene, which was capable of scanning the film image at HDTV resolutions and approaching 2Ka, 1556 GB. With the data option, the Spirit Data Scene can be used as a motion picture film scanner, outputting 2K DPX data files as 2048 A, 1556 GB. In 2000 Philips introduced the Shadow Telecine, STE, a low-cost version of the Spirit with no Kodak parts. The Spirit Data Scene, Sintel's seriality and ITK's Millennium opened the door to the technology of digital intermediates, wherein Telecine tools were not just used for video outputs, but could now be used for high-resolution data that would later be recorded back out to film. The DFT Digital Film Technology, formerly Grass Valley Spirit 4K/2K/HD, replaced the Spirit 1 datascene and uses both 2K and 4K line array CCDs. DFT revealed its new scanner at the 2009 NAB show, Scanity. The Scanity uses time delay integration sensor technology for extremely fast and sensitive film scans. High-speed scanning 15 frames at 4K, 25 frames at 2K, 44 frames at 1K. Equals pulsed LED triggered 3 CCD camera system equals, with the manufacturing of new high-power LEDs, came pulsed LED triggered 3 CCD camera systems. Flashing the LED light source for a very short time span gives the full-frame CCD camera a stop action of the film, allowing continuous film motion. With CCD video cameras that have a trigger input, the camera now can be electronically synced up to the film transport framing. There are now a number of retail and homemade pulsed LED triggered camera systems. An array of high-power multiple red, green and blue LEDs is pulsed at just as the film frame positioned in front of the optical lens. The camera sends the single, non-interlaced image of the film frame to a digital frame store, where the electronic picture is clocked out at the selected TV frame rate for PAL or NTSC or other standard. More advanced systems replace the sprocket wheel with laser or camera-based perf detection and image stabilization system. Digital intermediate systems and virtual telecines Telecine technology is increasingly merging with that of motion picture film scanners. High-resolution telecines, such as those mentioned above, can be regarded as film scanners that operate in real time. As digital intermediate post-production becomes more common, the need to combine the traditional telecine functions of input devices, standards converters, and color grading systems is becoming less important as the post-production chain changes to tapeless and filmless operation. However, the parts of the workflow associated with telecines still remain, and are being pushed to the end, rather than the beginning, of the post-production chain, in the form of real-time digital grading systems and digital intermediate mastering systems, increasingly running in software on commodity computer systems. These are sometimes called virtual telecine systems. Video cameras that produce telecine video, and film look some video cameras and consumer camcorders are able to record in progressive 24 frames S, or 30 frames S in NTSC, or 25 frames S mode. Such a video has cinema-like motion characteristics and is the major component of so-called film look, or movie look. For most 24 frames S cameras, the virtual 2-3 pull-down process is happening inside the camera. Although the camera is capturing a progressive frame at the CCD, just like a film camera, it is then imposing an interlacing on the image to record it to tape so that it can be played back on any standard television. Not every camera handles 24 frames S this way, but the majority of them do. Cameras that record 25 frames S or 29.97 frames S do not need to employ 2-3 pull-down, because every progressive frame occupies exactly 2 video fields. In the video industry, this type of encoding is called progressive segmented frame. PSF is conceptually identical to 2-2 pull-down, only there is no film original to transfer from. Digital television and high definition. Digital television and high definition standards provide several methods for encoding film material. 50-field S formats such as 576i50 and 1080i50 can accommodate film content using a 4% speed-up like PAL. 59.94 field S interlaced formats such as 480i60 and 1080i60 use the same 2-3 pull-down technique as NTSC. In 59.94 frame S progressive formats such as 480p60 and 720p60, entire frames are repeated in a 2-3 pattern, accomplishing the frame rate conversion without interlacing and its associated artifacts. Other formats such as 1080p24 can decode film material at its native rate of 24 or 23.976 frame S. All of these coding methods are in use to some extent. In PAL countries, 25 frame S formats remain the norm. In NTSC countries, most digital broadcasts of 24 frame S progressive material, both standard and high definition, continue to use interlaced formats with 2-3 pull-down, even though ATSC allows native 24 and 23.976 frame S progressive formats which offer the greatest image quality and coding efficiency, and are widely used in motion picture and high-definition video production. Nowadays, most HD TV vendors sell LCD televisions in NTSC/ATSC countries capable of 120 Hz or 240 Hz refresh rates and plasma sets capable of 48, 72, or 96 Hz refresh. When combined with a 1080p 24 capable source, some of these sets are able to display film-based content using a pull-down scheme of whole multiples of 24, thereby avoiding the problems associated with 2-3 pull-down or the 4% speed-up used in PAL countries. For example, a 1080p 120 Hz set which accepts a 1080p 24 input can achieve 5-5 pull-down by simply repeating each frame 5 times and thus not exhibit picture artifacts associated with Telecine judder. Gate weave, known in this context as Telecine weave, or Telecine wobble, caused by the movement of the film in the Telecine machine gate, is a characteristic artifact of real-time Telecine scanning. Numerous techniques have been tried to minimize gate weave, using both improvements in mechanical film handling and electronic post-processing. Line scan Telecines are less vulnerable to frame-to-frame judder than machines with conventional film gates, and non-real-time machines are also less vulnerable to gate weave than real-time machines. Some gate weave is inherent in film cinematography, as it introduced by the film handling within the original film camera. Modern digital motion stabilization techniques can remove both this and Telecine scanner gate weave. Soft and hard Telecine. On DVDs, telescenned material may be either hard telescenned, or soft telescenned. In the hard telescenned case, video is stored on the DVD at the playback frame rate, using the telescenned frames as shown above. In the soft telescenned case, the material is stored on the DVD at the film rate in the original progressive format, with special flags inserted into the MPEG-2 video stream that instruct the DVD player to repeat certain fields so as to accomplish the required pull-down during playback. Progressive scan DVD players additionally offer output at 480p by using these flags to duplicate frames rather than fields. NTSC DVDs are often soft telescenned, although lower quality hard telescenned DVDs exist. In the case of PAL DVDs using 2 pull-down, the difference between soft and hard Telecine vanishes, and the two may be regarded as equal. In the case of PAL DVDs using 3 pull-down, either soft or hard Telecining may be applied. Blu-ray offers native 24-frame S support, allowing 5/5 cadence on most modern televisions. See also. References. External links, explanation of Telecine methods.